Hi, welcome back. Today we're going to be talking about three key logarithms and how to change between them. We have the logarithm base 10, the logarithm base e, and the logarithm base 2. As a reminder, we can think about the logarithm as asking the question, what power of the base is x? So when we see an expression that says log base 10 of 100, we're asking what power of 10 is 100? Well, 100 is 10 squared, so log base 10 of 100 is 2. Similarly, what is log base 2 of 64? Well, 64 is 2 to the 6th power, and so log base 2 of 64 is 6. These are examples of the inverse relationship between logarithms and powers, where if we take the log base 10 of 10 to the x, we get back x, and if we take log base 2 of 2 to the x, we get back x, and if we take 10 to the log base 10 of x power, we get back x, and if we take 2 to the log base 2 of x, we get back x. Now this also works for log base e of x, which normally we write as ln of x for the natural log of x. We are asking the question, what power of e is x? And the natural log and the exponential function e to the x have this same inverse relationship. Let's take a quick diversion and talk about the number e and why it's so special. It's related to continuously compounding interest by this equation. It's related to beautiful calculus in that the derivative of the exponential function is the exponential function, but only when the base of the exponential function is e. And the derivative of this natural log function is 1 over x on the domain of the natural log function. It's also related to beautiful combinatorics. Let's say you go to a party and everybody brings a hat. If you want to return the hats back to the partygoers in some random way, the probability that no one receives their own hat is actually 1 over e, which is approximately 37%. So we have expressions of logarithms with multiple bases. It would be good if we could convert an expression involving one base to an expression involving another base. Let's talk about how that works. Let's say we have an expression, x, which is log base b of a. How might we write this using a different base, for example, c? Let's find an equivalent exponent expression. We get b to the x is equal to a. If we take log base c of both sides, then we get this, log base c of b to the x is equal to log base c of a. If we use the log power rule to bring down this exponent here, we get that x times log base c of b is equal to log base c of a. And then if we divide out by this log base c of b, we see that x is equal to log base c of a over log base c of b. So we've taken this expression, log base b of a, and we see that it's equal to log base c of a over log base c of b. I've highlighted that over here. Something important to notice is that in this fraction, the base of the logarithm is c in both cases. The argument of the numerator is the argument of the original expression, and the argument of the denominator is the base in the original expression. Now let's practice using this change of base formula. Let's say we need to convert log base 2 of 10 into an expression involving log base 10. We'll apply the change of base formula and see that log base 2 of 10 is equal to log base 10 of 10 over log base 10 of 2. What we've done is take the argument of the original expression, and that becomes the argument in the numerator, and we take the base of the original expression, and it becomes the argument in the denominator. Now we can simplify this. Log base 10 of 10 is equal to 1, and we get that the log base 2 of 10 is equal to 1 over log base 10 of 2. And this is highlighting a useful relationship. Log base b of a is equal to 1 over log base a of b. And that's true for every a and b that are positive and not equal to 1. Let's do one more example. Let's convert log base 10 of 800 to an expression involving log base 2. When I write log base 10 of 800, I see 800 as 8 times 100. We can write this as log base 10 of 8 times 100, and then apply our product rule that says this is equal to log base 10 of 8 plus log base 10 of 100. Now we recognize that 8 is equal to 2 to the third, and 100 is equal to 10 squared. And we can simplify this expression by 3 log base 10 of 2 plus 2. Now we'll use this useful relationship that we had from above and see that we can write this expression as 3 over log base 2 of 10 plus 2. That's it for this time. See you next time.